All right. Hi, everyone. Welcome to the Scaling Online ML Predictions at DoorDash session. My name is Hien Liu, and I lead the ML platform team. In this presentation, I will present the first part, and an engineer, Arbaz, on my team will present the second part. As for the agenda, first I'll share a little bit about the DoorDash Marketplace, then briefly talk about a few interesting machine learning use cases here, then discuss some details about the approach and the strategies we use for building our ML platform. And then Arbaz will talk about the main part of the presentation, which is about the scaling the online predictions. And then we'll wrap it up with the lessons learned and the future work. So DoorDash's mission is to grow and empower local economies. And we do that through a set of product offerings. The first one is delivery and pickup, where customers like you and me, we can order food on demand for breakfast, lunch, and dinners, or for various parties. And second is the emerging product called convenience and grocery, where customers can order non-food-related items, such as flowers, maybe charcoal for the barbecue, or maybe sugar for baking cookies. The third product is called Dash Pass, which is a subscription product that is similar to the Amazon Prime. DoorDash also provides a logistics platform that powers the delivery for some of the notable merchants that you see on the slide here, like Chipotle, Walmart, or Target. DoorDash platform is a three-sided marketplace, and like most marketplaces, it also has the flywheel effect. Starting from the center and moving to the right side, as we bring on more customers, there will be more orders. That creates more earnings opportunities for Dashers, and that improves the delivery speed and efficiency for the marketplace. And then starting center and moving to the left-hand side, as we have more customers, then there'll be more revenues for merchants. And as we have more merchants on the marketplace, the more selections there are for the consumers to choose from. As this flywheel speeds up, it brings benefits to all three parties. It drives more growth for merchants, creates greater earnings for Dashers, and bring more convenience and selections for our customers. Before going into a few ML use cases at DoorDash, let's discuss the primary concerns of each of these parts of the three-sided marketplace. At the top, we have merchants. They would like to increase the reach of their business and increase their revenue. And bottom right, we have customers that want convenience of staying at home while having access to a wide selection of items from their favorite merchants. And in bottom left, we have Dashers that want flexibilities in how they work while making good earnings. So the first use case, let's start with the consumers, where we have search and recommendations. In terms of search and ranking, we would like to show the most relevant results from the customer search query. For example, when a customer searches for Italian food, how do we best rank the restaurants in respect to the distance, the quality, and the customer's past order history? And for recommendations, we would like to provide a personalized food ordering experience for our customers by surfacing up the best stores for them. And for merchants, we want to help them to maximize their sales by providing targeted promotions for certain items at certain time of the day. For example, a promotion about a few dollars off from a certain pizza store between 6 and 9 p.m. And for Dashers, how do we best spend the right amount of money to bring new Dashers onto the platform? And once they onboard it, how do we mobilize them to come out at a certain night of the week due to high demand, or moving the Dashers to the right locations to satisfy the demand of the marketplace? For logistics, where there are many interesting and challenging machine learning use cases, its primary job is to dispatch the right Dashers at the right time for the right delivery to maximize the marketplace efficiency. The prediction of food preparation times and travel time estimates has a few interesting nuances, for example, like traffic and weathers, but we don't actually have control of. Another interesting challenge is, unlike Amazon orders, food orders emerge on the fly, and the food quality plays an important role in the delivery. The extra 5 minutes could be the difference between a great meal versus an awful one. Regarding our machine learning platform journey, we started about a year ago when DoorDash decided to invest in building a centralized platform. As you know, different ML teams have slightly different needs. So it's very important to establish the buy-in from those teams on the idea of a centralized platform. One of the ways to do that is to have the representation from each of these teams, as well as an open forum to voice the collective needs, opinions, and also be open to the contributions to the development of the platform. The collaboration model that we established include a machine learning council. It is responsible for making the cross-functional team decisions, such as build versus buy. It also acts as a glue for all these teams to work together and learn from each other. We don't claim this approach is the right one, but the one that works for us so far. These are the pillars of our platform that models after the machine learning development process. And it starts with feature engineering all the way to model predictions and insights. The approach we use in building these pillars starts with thinking big, right? Start with customers and work backwards to put together like a product vision document. Start small, building these pieces out incrementally based on the needs of the community, while keeping an eye out for the long-term vision. In addition, our strategies include velocities. How do we accelerate the machine learning development process? What projects or initiatives will help with this? We also want to build a cohesive set of pillars that work together seamlessly to provide the best experience for our ML community. And the last one is ML observability. We want to catch and prevent features and model-related problems before they happen, such as feature qualities or model prediction quality. We use these strategies to guide and help us in the prioritization of the effort of building our ML platform. One of DoorDash's culture values is about customer obsessed. And as a platform, we're only successful when our customers are successful. So all these parts, the architecture, the strategy, the success metrics, are all designed with that in mind. So now I would like to hand over to Arbaz to talk about the scaling ML online predictions.
Thanks, Hien, for walking us through the machine learning platform at DoorDash. Hi, everyone. My name is Arbaz, and I'll be talking about scaling the prediction pillar. As an AI platform, you've done all the hard work of building an end-to-end pipeline and serving models in production. As user growth starts to pick up and as company grows, the question is, will you be able to keep up the requirements of the scale? How are you going to keep costs in check while you're scaling out your systems? A model prediction is just one pillar of the machine learning platform, but for companies' day-to-day operations, it would be the most scrutinized one. With that, let's talk about scaling. In the current world of infrastructure as service, scaling is deemed trivial, assuming perfectly distributed systems. With this assumption, we think we can handle any kind of throughput requirements. The solution just scale horizontally. In reality, though, it's not a simple math game. And things start breaking much earlier than infinity. So the question one would ask at this point that how can I prepare myself to grow fast and meet all the scale expectations reliably? Now, there is no silver bullet or a fail-proof handbook to get you there, because there will always be a new problem you discover. But I have a short answer to this problem at this point. That how can you prepare for reliable growth? Here our journey. Here is talk today about the problems we faced and how we went past them. Oh, let me actually make it better. That keep hearing everything we share now on around our journey of building and evolving the machine learning platform. All right, done with the shameless plugs. The elixir, the portion here is just to keep doing what all of us are doing right now. Just like attend enterprises, narrate their experiences, and share our own. It's DoorDash's turn today, so let me do the honors. So I'll start first with the anatomy of a prediction to help build an essential workflow. This will be our common base for any further discussion. Then we'll start to scale this essential workflow and see things break. And as things will start breaking, we'll try to tackle and wrestle. We'll try to survive this collapse. You can expect a few wrestling picks there. And then finally, we'll talk about the challenges going forward. So here's a sketch of a prediction, just to understand the fundamental aspects of what's going out there. So the inputs for a prediction are the feature set and a model. The output is obviously a prediction score, and it's all mediated via a computation. Now, if I were to convert each unit into a scalable module, this is how it will look like. The computation engine can be horizontally scaled if it is put in a microservice deployment. The feature store and the prediction store, they're queryable, and so they're put as a data store. Now, since we're talking about production and a microservice, there's one important piece to be added here, which is monitoring and observability. We've got the essential design in place. These would be the core elements involved in scaling from a machine learning infrastructure perspective. And this is what we're going to discuss, like these particular elements. And so before we talk about the how of scaling, let's talk about the why and the what. So for the why we needed scaling, so one thing was to support more models in our framework. That was the first thing. Second was, as models get used more often, either due to the impact on the business use cases or they add new use cases, we want to be able to seamlessly support that. Third, we wanted to thrive and not throttle our callers when the product grows. And then last, incidental growth. We wanted to not be a bottleneck for incidental growth. What is incidental growth here? It's a situational uptick in demand. So for us at DoorDash, the last year, it was the pandemic, the IPO that we went through, or the Super Bowl teasers. That was what caused a situational uptick in our demand. Now, what exactly needs to scale? First, increase number of computations per interval. That is a throughput increase. With each prediction, you need features. So the features will have to, the feature QPS will have to grow synonymously. And also, as more features get added, some of these features are high cardinality. The another dimension to scale is the payload size of a prediction request. If a model demands for it, we need to be able to support it. And finally, allow more models to be stored and looked up. It feels that the top two are the more significant one for the more general use case, and at least for DoorDash it was. And that's what I'm going to now next talk about, that how we did the scaling for these two particular aspects. And we're going to do it through a time travel. Mind you, it won't be a smooth ride though. It will be a bumpy ride. We'll describe each bump that we hit and how we went past that bump. Right, so it's March of last year. That's when we finished building a machine learning platform. It was in its first phase. We have two models out there. We're making 1,000 predictions per second. And once the machine learning platform POC was established, our customers gained trust, we gained confidence, and things started to pick up quickly. As you can see from the graph here, by the time we hit June, we were at 16 models and making 15,000 predictions per second at peak. And also, there was other developments happening around the world at that time. The pandemic had started taking full effect, and DoorDash, being a food delivery industry, was seeing volumes escalate. However, our systems were also pushed harder. We started seeing pronounced effects of cannibalization. What is cannibalization? That some models consume more resources than the others. If you look at from the top to bottom, you see The highest latency that we saw for one of the use cases was 50 times more than the lowest one. And so the thought there is that, is the lowest latency model, the low latency model, is it getting overwhelmed because most of the resources are consumed by the high latency model? And so we start to think of isolation, divide and defend. So when I said expect some wrestling pigs, I was not being figurative. Here's an actual wrestling pig. So Big Show, as he is one of the biggest wrestlers in World Wrestling Entertainment and the federation that does wrestling. As the name suggests, he's meant to be like a dominating wrestler. His size commands his competitors to collaborate to take him down. Like usually one competitor is not enough. Here are two wrestlers that you see trying to take him down or trying to defend themselves in the process. And that's what we are going to do with the problem. We have this like large set of requests coming in. So what do? We begin sharding at the most overwhelmed connections. We start to make a clean divide in the system, all the way as far as possible, so that one use case does not overwhelm another. We have grew shards and we hit 6 figures in peak predictions per second. Also, our system layout now starts to look more like a model serving farm. Notice though that all this time there's this one shard which is taking more load than the others, the one with the red connections. And so that is what we call a fat shard, which is taking much more traffic than the others. Just take the case of recommendations for elaboration how a fat shard could come into being. When ranking content, in the case of DoorDash, for feed, homepage feed or carousels, you're doing thousands of predictions for a particular customer because you are ranking thousands of stores as compared to less than 20 for a cart recommendation, which you're just like considering the items in the menu of a restaurant. And so you'd expect that a feed ranking algorithm or feed ranking model will be hit much harder than a cart recommendation model. So this is when we hit that tipping point that one of our shards started growing much faster than the others. We were hitting AWS hardware limits. It was that big. We couldn't scale horizontally any further, but we still needed the predictions to keep flowing. And that's when we had to take our second tactic, which is beefing up. WWE was trying to promote a new wrestler some time back in the form of this wrestler called as Roman Reigns. They were giving him too many high-profile fights so as to gain reputation, but he didn't gain any fanhood regardless. So what did they do next to him? They tried to beef him up to make him look better, to make him more likable in the WWE audience. That's what does it mean for us? For us, it means that we have to run some exercises on the fat shard, make it leaner and more powerful. And so how do we do that? We do a bunch of optimizations. We try to go through this like whole round of observations and iterations. For microservice optimizations, in the observation part, we'll do some load testing simulations locally and in production and try to understand our limits. Also, we'll increase our instrumentation to closely understand bottlenecks. We'll do things such as latency profiling, or there's more specifically because we use gRPC-based microservices, we use gRPC tracing as a way for more observations, more understanding of what the bottlenecks are. And using this observations platform, we could exercise a few iterations and discover what works best. So there were some low-hanging fruits. We tuned the configurable parameters, such as the sizes of our payloads and how we batch our requests together, how much should be the batch size, other things such as the timeouts that we put on the connections. And a little more further, should we disable or enable bandwidth optimization? And then there were like more involved optimizations, which involved things such as aggressive compiler optimization flags or payload compression when sending requests. On the feature store side, we did similar observation iteration cycles. For the observation part, we did benchmarking where we tried to see that can we replace a feature store, which was an in-memory feature store in the form of Redis, with a disk-based memory store, and see if we can get more performance out of it, if we can cut the size of our cluster to be much smaller if we switch from an in-memory to a disk-based store. Too bad we found out that in-memory store is our cheapest solution and the most performant solution. So we started to re-engineer a feature store and do some optimizations natively within, in our case, Redis. Discovered some cool concepts there, which we have published a lot out there. And so with all these optimizations, it started working, and we breached the magic number of 1 million predictions per second, and the system was running stable all this time. It was a major accomplishment for us because we were able to take it even further. We were able to hold up traffic to even 2 million predictions per second. But it was not the end of our problems. There was one major unknown that was going to come to life. At this point, we had started hitting scales that would impact the entire DoorDash infrastructure. Mind you, the entire DoorDash infrastructure, because of one service. Think of implications such as bringing the entire site down because one of our service deployments went haywire. And this is not something that the wrestling world didn't teach us, though. Big Show, our biggest wrestlers of the generation, when got suplexed over the top rope by a beefed up Brock Lesnar, the ring broke with their combined weight. And this is what happened to us. A beefed up prediction service was facing this high volume of requests, and our infrastructure stifled as our logging and metrics infrastructure started breaching the limits. A console, a service discovery module got overwhelmed by our deployment so much that all these pods that we had spun up, they started continuously sending requests and updating their addresses, because of which all of the services were impacted. And so all of these things become part of that whole impact that infrastructure can have if a service grows that big. One of our third-party vendors called Segment for streaming, they started blocking us for sending too many events. This is what happened at that time. And so what did we do? We tackled them one by one. We started to cut our logging to bare minimum so that we just send only the logs that we need. For our observability, we moved from a pull-based monitoring framework in Startg to a push-based monitoring framework, that is Prometheus. We migrated away from a third-party streaming vendor to an in-house Kafka solution. Also, to help our service discovery module, we reduced our total number of pods employed by scaling them vertically, like increasing the number of vCPUs instead of increasing the number of pods that we had. And so this conscious and sampled use of resources allowed us to hit much larger volumes, 6 million plus predictions per second, which was great. It was part of a load testing for Super Bowl, and we were able to sustain that. However, there's still things that need to be taken care of as we try to strive for more and more growth. There will be these bottlenecks that will come to life again and start to push us to do more optimization, more scaling up. Yeah, so if you were to ask me in all this process, what were the 3 key takeaways? First is that isolate your use cases that don't overlap so that they don't overwhelm one another. If there's one use case that's being overwhelmed, it won't affect the others. Second, introspect. Keep your costs in check, keep that testing going, profiling, benchmarking, and reserve that time to scale up rather than scale out. And then lastly, note down your dependency that you have in the infrastructure and think of the implications that it can have, because those could be real serious ones. With that, I'm going to hand it over to Hien, who will walk us through the last leg of this presentation.
Cool, thank you, Arbaz. As Arbaz mentioned, the prediction service is a part of the production traffic flow. So ideally, it shouldn't cause any outage if something went wrong, like fetching features from feature store. So therefore, it's very important to have the proper default values in place as part of the model setup. For the second bullet point, in addition to collaborating with our ML teams closely, we also strive to understand the business problems that they're trying to solve, as well as the business impact. And for the last bullet point, we're building our platform incrementally, and it gives us a lot of opportunities to receive feedback, so we can make the necessary adjustments along the way, and that has been really helpful. For future work, as mentioned above, the prediction volume is increasing over time. So we look into the potential of caching the feature values as well as the prediction values. For the second one, so far most of the machine learning use cases are based on the structured data. Moving forward, we see more use cases in the areas of NLP and image recognition. So we need to extend our platform to support these model types. And for the last bullet point, as the ML platform adoption increases, we want to provide an easy and optimized way of making prediction requests for our customers. So that's all we have for you today, and thank you for attending this session. There's a link there to the DoorDash Engineering blog that you can find out very interesting blogs that Arbaz wrote and many other blogs.